system that we're going to look at in a little bit more detail in terms of homeostasis is going to be the heart rate and the cardiac cycle. The cardiac cycle is the rate, the cycle which pumps blood from your body, from it coming in at the atrium to being pushed out of the ventricle. That's the cardiac cycle. So, the cardiac cycle and your heart rate and your heartbeat is controlled mostly by your autonomic nervous system. What's the autonomic nervous system mean? Anybody remember?
Auto, sort of like, would that mean?
That's exactly that, Katie, yeah. Autonomic nervous system is the bit that we don't think about. It's the unconscious one that keeps your heart beating night and day, whether you're awake or asleep or thinking about it or not. Think about autonomic as automatic, really. It happens without you thinking about it. So your heart rate is controlled by your autonomic nervous system. And the autonomic nervous system has two separate branches we talked about. We talked about the sympathetic and the parasympathetic, didn't we? The sympathetic and the parasympathetic. Right? Anybody like to see if they can remember what does the sympathetic and the parasympathetic do? The sympathetic and the parasympathetic. What does the sympathetic do? It speeds you up, exactly. Well done. The sympathetic is the one that gets you going. It speeds rates up. And the parasympathetic is the one that slows them back down again. So in that negative feedback mechanism that we discussed, in terms of the heart rate, when the message comes that more oxygen is needed around the body, you need to get this blood pumping faster, faster, faster. Which one of these autonomic nervous strands will get the blood pumping faster? The sympathetic, exactly. When the message goes back to the negative feedback mechanism, we've got plenty of oxygen, cells are saturated, we don't need any more. Which one of these branches of the autonomic nervous system will control that? The sympathetic or the parasympathetic? Parasympathetic, thanks Harley, to slow it back down again, yes. So these work together, and it all happens automatically, autonomically, without you knowing about it, or really having very much control over it. Okay, so those are the roles of the sympathetic and the parasympathetic nervous system in terms of controlling heart rate. And within the negative feedback mechanism, they will be part of the message that goes from the brain to the body as to what changes to make, up or down. So, let's look first then at how the sympathetic nervous system will work on your heart rate to control homeostasis. It will come into play whenever you are in a situation where you're in fear or distress, or you have a lot of muscular energy work to do. We talked about the fight or flight mechanism. Why do you think, if you are in fear of something, your autonomic nervous system will speed up your heart rate? Why will that happen?
Will it be because your glands are raising the adrenaline?
Your glands raise the adrenaline, fantastic. And why do the glands increase your adrenaline?
In case you have to run.
In case you have to run, exactly. So your autonomic nervous system to do with your heart rate is part of your flight or fight mechanism. Okay? So it doesn't only work when you've been running for a long, long time, it also works if you feel under stress, because it's getting ready for you to be able to zoot off. Alright? It works together with the hormone adrenaline. As Katie said, your body also releases adrenaline. Can anybody remember which system is adrenaline part of? Your endocrine system, brilliant. Your adrenal glands sit on top of your kidneys. They're part of your endocrine system. Those glands are scattered all over your body. But if you need your heart to go faster, alongside your autonomic nervous system, your endocrine system will release adrenaline. Now, this is where we're going to link it very directly to the heart. Okay? To the heart. Here's your heart. This is going back a few weeks. This will test us all. Inside your heart, you have your inferior vena cava comes up this way, meets with the superior vena cava that way, and it goes into your right. Anybody remember what that was called? Atrium. Right into your right atrium, which goes into your right ventricle. Okay? This side, your left side, has your left atrium and your left ventricle, and they go up and down to your aorta. Alright? It goes out that way. They're the bits we're going to look at just now for the purposes of this bit of the work. Anybody remember where is heart rate controlled from? The right. Yeah, the top of the right atrium, there is something called the sinoatrial node, or the SA node, the sinoatrial node. All right? And the sinoatrial node is part of the sympathetic and the parasympathetic nervous system. Because what happens when your body detects that more blood, more oxygen is, or more nutrients are needed, it sends a message to your sinoatrial node. And what your sinoatrial node is a little bundle of nerve fibres that are very, very excitable, very, very twitchy, very, very quick to react. And what that message says is, speed up heartbeat, because the sinoatrial node is the pacemaker of your heart. It tells your heart when to beat. At that sort of beat, normally. If we need more oxygen sending around the body, the pump needs to speed up, the sinoatrial node will tell your heart to beat more quickly. So, the sinoatrial node sends a cluster of impulses, well, I'll use a different coloured pen here for you to see, sends a cluster of impulses out from the sinoatrial node, and it tells the atria to squeeze more quickly and more forcefully, to squeeze that blood down through the valves into the ventricles, ready for signals around the body. At the bottom of the sinoatrial node, there is another little one called the atrioventricular node, the AV node. And what this does is it sends all the nerve messages down some little nerve fibres called Purkinje fibres that then go around the ventricles and get the ventricles to squeeze more quickly and more forcefully as well. So the message sort of spreads out from the SA node to the AV node and around the heart. Get going, get going, get going, faster, faster, faster. And that is the sympathetic nervous system that works on those nerve fibres in the sinoatrial node to speed up your heart rate. Okay, anybody got any questions about that? No? Okay. So that's how your sympathetic nervous system speeds up your heart rate. Right, if you haven't got any questions then. Right. So, on this diagram then, we can see here is the sinoatrial node. The nerve fibres go out to both the atria. They also go down to the atrioventricular node, which passes down through the Purkinje fibres that go around the ventricles. And they send the messages all around your heart to speed up. Okay? So, fine. Heart's going faster. How is that linked to your brain then? Because your brain's part of this system as well. This is negative feedback. It goes from the organ to the brain, to the body, to the organ to the brain, round and round and round. So we now need to think about how this links to the brain. Are you okay? Yeah? Right. The part of the brain which is linked to the control of your heart rate is called the medulla. And it's this bit here, at the bottom of your brain, the medulla. It's sometimes called your brain stem. And your brain stem is the bit of your brain that controls all of those involuntary things such as breathing and respiration rate. And that's why if somebody talks about somebody having an injury to their brain stem, it's very unlikely that they will survive that injury, because that means that their systems for breathing and heartbeat will be knocked out. So it's a very, very delicate part of your brain there, a very important part of your brain, your medulla. That's where your sympathetic and your parasympathetic nervous system links up. All right? To your brain stem. And it works in two separate bits. It has the cardio-inhibitory centre. The cardio-inhibitory centre. There's a lovely drawing of your brain. Your medulla's about here. And it has your cardio-inhibitory centre. If it's got the word inhibitory in it, what do you think that does? Do you think if it's inhibitory, do you think it speeds up or slows down? It's inhibiting. Speeding up or slowing down, what do you think? Inhibits. Slowing down, exactly. The cardio-inhibitory centre slows things down. If it slows things down, if it slows your heart rate down, is that part of your sympathetic or your parasympathetic nervous system? Parasympathetic nervous system. Yep. Your cardio-inhibitory centre is part of your parasympathetic nervous system. It slows things down. And it does it in a really, really clever way. This is a bit of information which is just fascinating. It's connected to something called your vagal nerve. Your vagal nerve is the biggest nerve in your body. It starts up here and it goes all the way down your body, past your digestive system, right down to your groin. It's called the vagal nerve. It goes all the way down to your, right the way down through your body. It's one of the nerves, it goes past your ear. And it actually depresses respiration, which is why sometimes things in your ear can be quite dangerous to your breathing, unbelievably. That's why with older people, if they are trying to see if people are responsive, they might sometimes put things in their ear to see if it affects their respiration rate, because of that vagal nerve.
That is very cool.
Are you okay, folks? Have you got questions to ask? Have you got questions to ask? No. You okay? I know this is a bit lengthy, but I'm going to stop talking in a minute and get you to start doing your activity. Okay?
What would happen if you damaged your vagal?
It depends how damaged it is. I mean, other systems work alongside it. It can be quite destructive. I'm just going to stop for a second because... Yeah, Lani. Liv.
I was just like in the middle of writing down many times about that mare. Can you just quickly say what it does?
It's part for, in terms of your respiration, it's part of your parasympathetic nervous system, and it sends messages to your heart to slow your heart rate down. So that's part of your cardio-inhibitory centre in your medulla. The other part of the medulla that works here is the vasomotor centre. Okay? If it's got motor in it, what do you think its job is? To speed up, exactly. To speed things up. So is that part of your sympathetic or your parasympathetic?
Sympathetic.
Fantastic. Sympathetic. Oh, you're getting it now.
Yeah.
It's hard, isn't it? It is really complicated. But once you start to see it coming together, you really start to see how it comes together and works.
I don't remember all the names.
Right, shush. Enough talking. Right, so that your Purkinje fibres and your sinoatrial node are connected through nerve receptors to your medulla. And they work through the cardio-inhibitory or the vasomotor centres in your medulla. So, if in the negative feedback mechanism, if you are needing to, if you've been running and then you go to a walk and you don't need as much oxygen anymore, which bit of your nervous system will be used in the negative feedback mechanism? Your parasympathetic, brilliant. Your parasympathetic nervous system will send a message through the negative feedback mechanism to say, slow down. Which nerve will it use to send that message? Your vagus nerve, excellent. And which centre of your medulla will it go to? The cardio-inhibitory centre. Then if you need to start running again, which bit of your autonomic nervous system will work? Your sympathetic or your parasympathetic to speed you up? Sympathetic, brilliant. It will send a message from the vasomotor centre in your medulla to your heart. To which bit of your heart? Which bit of your heart makes your heart beat? Sinoatrial node to speed it up. Right. Good. It's complicated, but if we just take it a step at a time, we will be able to understand it. Right, the next bit is to do with the aorta, the other receptors in your body. How does your body know that it needs more oxygen, or that it's stressed, or that blood pressure is too high or is falling? How does your body know that we need more blood going round? Well, it knows because you've got receptors all over your body. We talked about these at the beginning of the session. There are nerve receptors and there are chemical receptors. So, in the aorta and the carotid arteries, there are little nerve receptors called baroreceptors. And what they do is they can tell when the blood pressure in your body is going up or falling. So it says, we need more pressure, we need more blood. And it will give a message to the brain about the amount of blood and the pressure of blood in the body. Where is the aorta? That's right, Michaela. It's a very large artery that comes out of the left ventricle, up and out of your heart, okay? Where's your carotid artery? That's a more difficult one. We talked about this when we talked about the lymph system. The lymph system drains into your carotid. Subclavial. It's in your neck, your carotid. It's a big artery in your neck. So in your big arteries, carotid and aorta, there are little nerve receptors that will say whether or not blood pressure is falling or increasing to tell the brain to get the heart to speed up or slow down. They send information to the vagus nerve or the vasomotor centre in your medulla. The other thing that happens at times of stress which we mentioned at the beginning, was that your endocrine system works too and releases adrenaline. Your adrenaline works on your sympathetic nervous system to help speed up the sinoatrial node. So those are the ways in which your body works to maintain homeostasis. And what that homeostasis does is it gives your body the right amount of blood, nutrients, fluid circulating around it, but it also works to keep it within a range which is safe. Because obviously, if you've got a heart, your heart rate can't just carry on going up and up and up and up and up. It can't go up to 300 beats per minute. Similarly, if it drops down and down and down and down because you're just lying asleep in bed, it can't drop down to 5 beats a minute. Otherwise, your body's not going to function. So it also works to keep it within that homeostatic band. Right. So, quite a challenge now I've got for you. I will turn this off.